is a Kinder Joy toy. And if I did an auction for all my Kinder Joy toys, I would be a millionaire. That reminds me, we're going to write an auction contract today. Hi everyone, this is Sneha from Web3 Compass, and it is day 4 of 30 days of building with Solidity. So for everyone who is not aware about this campaign, you can go over to the first video. That is where I talk about the entire campaign in detail, or you can head over to web3compass.xyz and check it out yourself. For the rest of you who has been bearing me for the past 3 days, here we are for day 4. Let's dive in. So today we're going to write a smart contract which is related to an auction concept, and it's called AuctionHouse.Sol. The concepts that we'll be talking about is if-else statements, block.timestamp, which is a global variable, basic bidding. Okay. As an example application, I would say, let's create a basic auction where users can bid on an item, and the highest bidder wins when time runs out. You will use if-else to decide who wins based on the highest bid and track time using the blockchain's clock, block.timestamp. This is like a very, very simple version of eBay on the blockchain, showing how to control logic based on conditions and time. Now let's move forward. Let's head over to Remix. We'll create a file here. Auction house dot sol. Okay, so to save our time, because this is going to be a lengthy video, and also because I don't want to type it down, I've had enough practice, we will just do our ritual. I hope everyone knows what I am doing here. Now let's get started. Okay, so when you hear of, an auction, or maybe let's take an example of eBay, like I mentioned, a very basic version. Someone puts up an item for sale, other users can bid on it, and when time runs out, the highest bidder wins. No manual tracking is happening, no guessing is happening, no favoritism is happening. Straight away, process that is set up to just go about it. Very simple key. Okay, whosoever is bidding it, whosoever is the highest bidder will just go about it. Okay, so now the contract is called Auction House. Through it you will learn how blockchain has a built-in time using block.timestamp, accept and compare bids, use keywords like require, if-else statements to write logic and implement the functions that we're trying to do, and also manage users, arrays and mapping. For everyone who does not know arrays and mappings, you can just head over to the previous video and learn more about it. So let's just lay out things. Okay, what kind of data do we actually need for an auction? Okay, so before we write any functions, we should think about what are the aspects that we need to keep track of, like variables. What are the variables that we're going to declare? Okay, so in an auction we need to know who is running the auction, what item is being sold, when does the auction end, who is bidding and how much, who is in the lead, that is who is the highest bidder, or who is leading if there are multiple bidders, and whether the auction is already over. Now you can have multiple other things like, okay, for every item there's a minimum bid, and only you can put in certain more criterias where maybe multiple bids are happening and all of that category, but we'll just keep it simple here. So okay, in order to figure out who is running the auction, right, we would need the wallet address, and for that we will use the address data type, which captures the wallet address, whosoever is running or doing a transaction, whatever it is. When we say we are declaring the variable as owner, why? Because we want to figure out that who the owner of the auction should be, right? And then what are the items that are being sold? So we will just say, okay, let's create string public item. Again, all of why are we writing public, why it should be accessible, what is a string data type, we've covered it in the previous video, so I'll not repeat it here. You can just go quickly watch it there. Then maybe what is the auction end time, right? So we'll just say, okay, uint public action end time. For everyone thinking that I've made a mistake here and not wrote uint 256, no, it's totally fine. There are different slots of data that we are talking about, uint 8, 32, 16, 128, 256. So generally we go about with 256, but if you know that it's going to be a smaller value, you can just go with, you know, any smaller data type or data size. Okay. Now, okay. So now we also want to know the address of the highest bidder, or who's currently the highest. So we'll just write another address. We'll keep this private because we do not want people to know that who the highest bidder is and what is the value that is going to be. Because if I know that my Kinder Joy toy is going to be sold for $10, someone else who has an eye on it will take it for 12. And then someone else who knows, oh, the highest bid is 12 and they want it, they would just say, oh, no, I want to bid it for $14, right? Or maybe just increase the price a little, 12.5, and boom, you are the winner, right? So we would want to keep it private, and that is why we are using the private keyword here. Now, okay, so AI is already suggesting uint 256, private highest bid. Let's remove this. We'll come to this later. And now what else? We wanted to know if the auction is currently active or not. So we will set up a Boolean value. For Boolean data, we use the keyword bool. That is a data type here. And we say, oh, public ended. And it will have values, okay, true or false, whether it's active, it is not whatsoever. Now, what else is it that we're going to talk about, right? Now, with every wallet address, okay, suppose it's me, say to someone else, I put $12, say to the 13, the XYZ person did 14. So with all of our addresses, don't you think that we should have the value stored somewhere that for this particular wallet address, we have this much bidding that has happened, right? And what is it that we need in order to store something like that? Mapping, exactly. Again, everyone who does not know what mapping is, just go back to the previous video. You have all of that information. So we need wallet address, so the data type will be address, and we want integer value of what the person has bid. So we'll just say, okay, it's uint 256, and we say let's keep it public, the mapping, and just say, oh, bids. Okay, now if there are multiple people who are, you know, bidding for the auction, we might have to store their addresses. So we'll just go with an array instead of just storing it manually, and we'll say, oh, public bidders. Great. So now we're done with all the variables here. Most of it, we can figure out the rest while we, you know, proceed with the time, with the session. We see if we need anything else. And then, okay, AI is suggesting that we need to write a constructor and say owner equals to message.sender. What's that? Right? Like, what is it that it wants to tell us? Is it wrong? No, it's not. Okay, so there are certain things that we need to set up when the contract is deployed, and we want to put a condition where it says, okay, only the owner of the smart contract is supposed to be someone who starts the auction, right? And as you know that with Constructor, it only runs once, right? Exactly when the contract is deployed. So what we will do is we'll provide some parameters and values there so that once the constructor runs on deployment, everything is set and now it's not going to change. Okay, so we say, okay, constructor, that's the keyword. And what do we want? Okay, we want the item and we want the bidding time that we want to set. Okay, now we'll create a string again. With string we have memory, and we say item, and then we say uint 256 bidding time, right? And in the constructor, oh, that looked better here. Yeah, it looks good now. Okay, so we say, since we already had an address, or yeah, an address variable called owner, we'll say that owner equals to message.sender. Okay, let's just remove this. Okay, and then we say, in the item string that we have created, we will add the parameter value that we have given with the constructor, which is an underscore item. Again, it's a naming convention, guys. You can give it any name, but as a good practice, and it should not be very difficult to remember, we just add an underscore to it. And then we say, okay, now that we're looking at the bidding time, we want to set up auction end time, which is block.timestamp plus the bidding time that the user is going to provide. Okay, and all of this is supposed to be done by the owner, okay, whosoever is running the smart contract. So owner equals to message.sender is, it saves the wallet address of whoever deployed the contract here, and that person becomes the auction owner. And item we have already discussed. For the action, oh, that should be auction end time. Yeah, for auction end time, why does, okay, I've written action end time here as well. So for auction end time, we are setting block.timestamp, which gives us the current blockchain time, and then we can add how many seconds that we want the auction to last. Okay, so if I have to provide values to it and I want the auction to end to go on for like 5 minutes, it has to be 300 seconds that will be given as the input. Okay, 300 seconds, because we want to do 5 minutes. So once we deploy it, you need to know that we're giving it in seconds and not any other format. Okay, now what do we do next? Okay, we say that now that we have declared variables, we've talked about constructor, it's time to implement the function, right? So we say, okay, I want to make the bid. I'll keep the function name bid. Now obviously it has to be uint. Now we'll talk about these later, okay, but we'll talk about something called as external, which is again a visibility specifier, which lets people outside the contract access it. Okay, none of it will happen internally, like in the contract. When we were talking about public, it is accessible to all. When we talk about a visibility specifier called as internal, so for that contract as well as to all the contracts who are actually inheriting this contract, again, inheritance is a different concept we'll talk about later, then internal will work. For private, we're just talking about a particular contract, and only there the function is acceptable, but for external, it's just accessible from outside. Okay, now what we say is that, you know, we're dealing money here. Money is a dirty practice. Okay, so we have to be very, very careful. So we'll put in a few conditions to be very sure that we do not bid at the wrong time and the transaction goes well and whatsoever. So we say, okay, we need to check a condition for which we'll use a required keyword, and it says, okay, block.timestamp, which is the blockchain's time, is less than the auction end time. Okay, like whatever we have decided, and it has to be, right, because we are talking about the bidding time here, but with required statements, it checks for a condition and then it has to have a message that, hey, you know what, now we're checking what? we're checking block.timestamp less than auction end time. Why do we have a dot here? We have a comma. We say auction is yet, auction has already ended. Okay. Why is it showing things like this? Function bid, relevant source path starts here and spans across multiple lines. What is the problem? What is the problem here? Okay, let's see what is the issue here, and we'll just continue with the entire thing. Okay, so it is checking the condition. If block.timestamp is less than auction end time, that means the condition is working fine. If not, then it says, oh, auction has already ended. That is how we provide the condition here. We put another condition which says require amount has to be greater than 0. Okay, if not, it says bid amount must be greater than 0. Okay, so the issues thing has appeared again. Now what is it that we want? We've set up conditions for block.timestamp, we've set up conditions for amount. Now what else? Okay, if I am bidding and I said, oh, okay, $12, my next bid cannot be lesser than $12. Okay, I'll just say you need to bid higher, right? So that is also a condition that I will check that, hey, you know what, require amount has to be greater than bids message.sender. Again, message.sender is the person who is doing the transaction, who's calling the smart contract at that moment. It's a by default value that gives you information. So if I am running the smart contract, message.sender will have my wallet address or the account address from which I am performing the transaction. If you are running it, it will store your address. So it says bids must be higher than your previous bid. Okay, let's go. Okay, now that we've written all of the required conditions, we'll just start implementing things like check who is bidding, store their new bids, and let's see how we'll do it, right? So we say, okay, if bids message, so bids is the mapping that we had created here, and we say, okay, if bids.message sender equals to 0, then you do, oh wait, what have I done? Okay, so we are missing one curly brace. Let's fix that first. And then we say, okay, if bids message dot sender equals to 0, we say bidders, which is the array, okay, bidders dot push message dot sender. Okay, that means that this is the first time this person is bidding, and we add them to the list. Okay, so all of our whatever lines they are called, they've disappeared. Now we say that, okay, we need to store their new bid. Once we have pushed them, we need to store their new bid. So we say, okay, bids message dot sender. Now it always just adds the closing bracket at the end. So we're saying, okay, for this particular message dot sender, which is the current person who's trying to bid or is bidding, we store the amount. Okay, now we have to say that, okay, now we also need to check if they are the new leader or the highest bidder that we are talking about. So we say that if, okay, we'll check with the amount, right? So if amount is greater than highest bid, then very simple, we say highest bid equals to, oh god, highest bid equals to amount, because we're checking that, oh, the current amount is greater than whatever highest bid that we have stored right now. And then because this particular message.sender has bid that value, we say, okay, highest bidder is message.sender. So everything works fine here. We've added a few requirement conditions. We're checking, okay, what is that this person is bidding, who is going to be the highest bidder, and all of that. Ignore AI here, right? I've just messed up with the, what is it? Alignment of the code, but it's fine. Okay. So yeah, every time we have to check these conditions to check whichever is the highest bid currently and who is the person. Okay, now that we have done this, we want to just we just want to end the auction. Okay, we are like, okay, let's just get done with this. So we'll create another function that says function end auction. Okay, now we're not expecting anything out of as such, so we say external. Again, why? What have I done, sir? Okay. We want this function to be out of the previous one. So we will check that this is the closing of this particular function. Okay, works well. So yeah, end auction, and we have to make it external so that again it is accessible. And we say, let's check. How are we going to check? We have to check it with the block.times stamp and then see what was the auction end time. So we say, okay, if require block.times stamp is greater than or equals to auction time, that means the auction is ended, right? But if not, then it says, oh, auction has not ended yet. So with whatever condition that we are providing, whatever is the opposite of it, that is supposed to be printed. Okay? Here also we said, okay, block.timestamp is less than auction end time. So in that case, it could have worked, right? But then we say, okay, if this gets true, then what is the opposite thing? That means it's still running, right? So this is true, then you have to go about, okay, no, auction is ended, because we are looking at the negative of the entire thing. And then we say, okay, require, we're putting another condition that, okay, if we would have said ended, what is the opposite of it, right? We're putting ended, not operator, okay? So then auction has, auction end has already been called. Okay, I hope this part is clear. See, if this would have been, if this is the condition that we are checking, ended, that means, oh yeah, auction is end, but we're looking at a negative value of it, that means it has not ended, right? And then with whatever is the condition that we are checking here, we are going to write the exact opposite of what we are doing here. Okay, expected this, oh, we forgot a semicolon here, it's fine. Auction time, oh, auction end time, yeah, we've not declared that variable. Okay, and then we set this ended equals to true. Okay, so we're checking two things here, we're checking two things here. Has the deadline passed and has it already been marked as ended? If both checks pass, we flip the ended flag to true. From that moment, no more bidding is actually allowed. And then we say, okay, we bid the, we're done with the bidding function. We've already checked and made sure that the auction has ended. Now what? It's result time. Okay, so we say function get winner. We want to know who won. So we don't have to pass anything. We're just expecting a return type here. So we say external. Again, every function that we're talking about here is external. It has to be accessible from outside. And since we do not want to do any changes here, we'll go with a return keyword and we say, okay, returns. What is it that we're expecting? Because we want a winner, we need an address type and also the amount that the person has bid, right? And that is what we're going to specify. Now we have to check that has the auction already ended to actually be able to, get the winner. If not, then we're saying, oh, auction hasn't ended yet, which is totally fine. So we'll wait and then we'll say, okay, my God, what is wrong with me today? Yeah. And oh, not required, it should be required address. Yeah, okay, so that is a warning. We'll say we need a return. Sorry guys. Yeah, so we need the highest bidder. Again, that is what we had as address and the highest bid of it. So AI is right here. Highest bidder and highest bid. That's it, right? That is what we need to get the winner. So we're done with another function. Now, so we only want this function to be called after the auction is over, and then we address the, then we return the address of the highest bidder and the amount that they've bid. Now, we would also want to maybe have a helper function, okay? Like I want to implement it that, okay, we've got the winner, but I also want to see that who all were bidding, right? Maybe not the amount, but I want to see how many people participated and showed interest in my Kinder Joy toy. So I'll say, okay, function get all bidders external. Again, we're not expecting anything out of, like, to change anything. We just want a return value here. So we say returns. Now what is it that we're expecting? We want all the bidders value to be visible. So we just say address, right? And memory here, and then we say, okay, return bidders. Yeah, right? That is as simple as that. We do not have to like really go about this entire thing, but yeah, works fine. So we'll just quickly compile it. We did not look at any other compilations today. Oh, the previous contract again as usual. So today with the deploy, you will see that we already have to, provide a value here in terms of item and as well as the bidding time that we're giving it. Okay, so I say, I want to sell off my iPhone so that I can go on a vacation. And I would want 2 minutes, 120 seconds, right? I say, okay, transaction. Then, oh, wait, I have another iPhone that I would want to sell. Okay. Yeah. So both of them went through. Sorry. Okay, yeah, let's, so I deployed it twice, so just let it be. Now here you will see all the functions: bid, end auction, get winner, get all bids, etc. Now I want to put like 2. Like everything that we're talking about, payable, we're talking about in terms of ETH, and that is how the transaction will happen here. So I say, okay, transaction, it went through. What is the auction end time? So this is what we are getting in terms of the, timestamp here. who are the bidders, right? So we've not actually added, but we'll get the owner of the bidder. This is me calling the bid, like calling the auction. So this is the address that we have here. Now for item, we have iPhone 15 Pro. For bids, let's just, oh, please ignore that. For bids, we want to add address. So I'll just quickly shift to another, I'll put another, bid. And I say transact. It says invalid big number. Okay, sorry. No decimal values taken. So I will say 1 and this should go through. And then you will see, okay, if I want to call bidders, call. So this would be my previous address, but let us just try for 1 and call. So you will see that this is the exact same address from which I've done the transaction, and I placed my bids, right? Similarly, if I want to just copy this, okay, this account, and I say, okay, paste this, call, and it says, oh, 1, right? And I want to make sure if get all bidders, yeah, very simple, both the addresses, that is there, one item only, we're not adding any other items as such, but instead we could have made this actually an, array, multiple items in there, but here we're only talking about one item altogether, and I want to call this ended so that the auction ends, and let's check. Okay, we go auction end time. Okay, that is there. So right now it has not ended, but I say end auction, it went through, and then check ended, and now it's true, right? Let's go for get winner. So because I had bid 2 ethers here, right? 2 is the value. Here is my address that acted as the winner, right? If I would have maybe done something else, it would have, if I would have put another value from my different address, it would have been something, some other address would have been the winner, right? So as a final recap, we would just talk about what did we just build. We built an auction contract that can track time using block.timestamp, let people place bids. We're only talking about one item here, so feel free to make it an array, automatically track the highest bid, prevent any last minute changes after the time is up, so you're calling that particular function, checking if it is true or not, and reveal the winner with like 0 manual effort, no calculations happening. And in this particular section, we talked about the concept of require, how we are checking conditions, comparing values with if, storing per user data with mappings, and also use arrays to keep track of multiple participants. What would be next steps for this is that right now it's not actually handling real funds, right? Like I just mentioned that, okay, it's 2 ether, but we've not really made it payable. It's just logic, okay? So now we look at accepting actual ETH. That is what, I was actually mentioning when I said the payable keyword, but don't get overwhelmed. We will talk about that keyword as well in the coming lessons. Right now, you just have to assume that, oh, we've given it as a value 2, 1. Just check if all the conditions are working fine. Maybe add option which says, okay, if I bid, someone else bid, and somebody else wins the bid, then I get my money back. Okay, so there's like a refund facility. But right now what we have is a very clean, gas efficient, very easy logic implementation of the auction contract, and a very particular foundation to build on. But yeah, I think that's it. Please keep building, and I will see you in the next one. Right? Please reach out to us for any questions, and yeah, happy to see you building. Bye guys.